I want you to do something simple. Go ahead. Look at the second hand on a clock or the timer on your phone. Watch it tick. 1, 2, 3. Now here's the disturbing part. Which one of those ticks is now? You'll say this one, obviously. And if I'm standing next to you, I'll probably agree. But if you and I are moving relative to each other, fast enough or far enough, physics lets us disagree about which events are happening right now, and both of us can still be correct. Here's the question that keeps me up at night. If now isn't universal, then where is your future right now? Not where will it be, but where is it, as a location in the four-dimensional thing we call space-time? Because in Einstein's relativity, time isn't a cosmic drumbeat everyone shares. It's more like each observer carries a private rhythm, and those rhythms don't line up the way your gut insists they should. And I'm going to promise you something. By the end of this talk, you'll understand why some people think the universe is a kind of block, where past, present, and future are all there in the same way different places are there. And I'm also going to be honest, that block universe is an interpretation, not a proven fact. We'll treat it like a serious suspect, not a convicted criminal. One more uncomfortable statistic before we go deeper. GPS satellites must correct their clocks by tens of microseconds per day because relativity isn't optional. It's built into your directions app. That's not philosophy, that's engineering. So, are you ready to find out what right now really means? Let me tell you something that will change how you see time. You've spent your whole life with a quiet assumption. You don't even notice it, like you don't notice gravity until you jump. The assumption is that the universe has a single spotlight called the present, and it sweeps forward, and everything it touches becomes now. But what if that spotlight is not in the laws of physics? What if it's in you? Now wait, before you roll your eyes and say, "Here we go, another spooky time video," I want you to keep one foot on solid ground. We're not starting with poetry. We're starting with clocks, the kind that run your phone, your bank, and your GPS. Because if relativity is right, the present is not a global property. It's not painted on the universe like a label. It's stitched to the motion of whoever is looking. And that's the disturbing question. If there is no universal now, then how can the future be not yet for everyone? Some people hear that and immediately jump to the block universe, the idea that all events in space-time are equally real. Others reject that and say time still passes. We just can't define simultaneity globally. The honest truth is, relativity forces the first puzzle, but it doesn't force one single metaphysical answer. But it forces you to look. By the end, you'll be able to take a simple thought experiment, just lightning in a train, and see why your future could already exist in someone else's now is not a gimmick. It's a precise consequence of how you define time using light signals, source. And then we're going to ask the personal question. If physics doesn't contain a universal present, why does your life feel like it unfolds in one? Most people think time is like a river. It flows from the past through the present into the future. You stand on the bank, moments drift by like leaves. You can remember upstream, you can't visit downstream. That feels so obvious that questioning it feels like questioning whether you have hands. But here's the thing. Physics doesn't start with rivers. Physics starts with operations. What do you do to measure something? If I ask you, what time is it here? You look at a clock. Fine. But if I ask, what time is it over there? Across a field, across a city, across space? How do you know? You need a method to synchronize clocks. Einstein's 1905 paper doesn't begin by declaring time weird. It begins by noticing something almost boring. If you want to talk about time at different places, you have to decide how to synchronize clocks using signals, light signals, source. You might think there's a single correct synchronization, because surely the universe has a master clock. But actually, in special relativity, there is no master clock that everyone can agree on, because the speed of light is the same for all inertial observers. That one fact forces a radical consequence. Simultaneity becomes relative. Let's name our first scientific term, simultaneity, meaning two events happening at the same time. In Newton's world, simultaneity is absolute. In Einstein's world, simultaneity depends on the observer's state of motion. Now here's your first "wait, that doesn't make sense" moment. If simultaneity is relative, then what you call present is a slice through space-time. And different observers, moving relative to each other, cut different slices. That means your now can include events that someone else calls already happened or not yet happened. But here's the thing, nobody experiences that directly at walking speed. At human speeds, the difference is tiny. It's like the thickness of a hair compared to the width of a highway. So your intuition never gets trained on it. Still, it's real, and we can prove it in ways that are not subtle. Consider GPS. GPS works by time-stamping signals from satellites and comparing them. If the satellite clocks drift even a little, your position estimate drifts a lot. Relativity predicts that a satellite's clock rate differs from clocks on Earth due to both speed and gravity, and GPS systems include relativistic corrections on the order of tens of microseconds per day. A microsecond sounds small until you convert it into distance. Light travels about 300 meters in 1 microsecond, so tens of microseconds is kilometers. That's not an academic footnote, that's you missing your exit. Now let me give you a metaphor from everyday life. Think of time like a movie stored on a hard drive. When you press play, you experience it frame by frame, but the file itself contains the whole sequence. Your experience is moving, but the data is all there. That metaphor tempts people toward the block universe. But careful, metaphors can seduce you. They don't prove anything. So we need the actual mechanism. Second term, space-time, the union of space and time into a single four-dimensional structure. In 1908, Hermann Minkowski famously argued that space and time aren't separate arenas, but aspects of one geometry. He put it sharply, henceforth space by itself and time by itself are doomed to fade away into mere shadows. That line is poetry, but it's attached to math. Third term, inertial frame, a viewpoint moving at constant velocity, not accelerating. In special relativity, each inertial frame has its own natural definition of time and simultaneity. Now here's the first major scale comparison. The whole argument can begin with something as small as a light pulse crossing a train car, but it ends by forcing you to rethink the entire history of the universe, billions of years, because now is not a single cosmic boundary. And here's one impossible sounding number to sit with. There are about 10 or 80 atoms in the observable universe. That's a 1 followed by 80 zeros. Your brain can't picture that, and yet your everyday feeling of now assumes a global coordination across all that matter, across all that distance, like a conductor keeping time for an orchestra spread across billions of light years. You might think the universe must provide that conductor, but actually, relativity never installs one. So what does? Layer 1. Let me explain this the way I'd explain it to a bright 12-year-old. Imagine you and I are on a long train. Lightning strikes the front and the back of the train. Now we ask, did the strikes happen at the same time? If I'm standing on the platform midway between the strike points, I see light from the front and back arrive simultaneously. I say, the strikes were simultaneous. But if you're standing in the middle of the train while it moves, you're moving toward one flash and away from the other. So you receive one flash first. If you use light arrival times to infer when the strikes happened, you conclude they were not simultaneous. Now you might protest, but one of us must be wrong. That's the instinct Einstein attacks. In his setup, both observers use the same rule. Light travels at the same speed in their frame, so they construct time using that. The result is, simultaneity depends on the frame, source. And this isn't a trick, it's baked into the structure. Here's another simple analogy. Think of drawing a now line across a map. On a flat map, east is consistent. But on a curved surface, different people draw straight lines differently depending on where they are. In space-time, now is like a line you draw through events, and different motions tilt that line. Fourth term, relativity of simultaneity. The fact that different inertial observers disagree on what events are simultaneous. Now, thought experiment time. Suppose you're on Earth and your friend is in a spaceship passing by at a significant fraction of light speed. There's an event in your future. Say, you will press a button tomorrow. In your frame, that's tomorrow. In your friend's frame, because their now slice is tilted relative to yours, that event might fall on their slice of now at the moment they pass you. What does that mean? Does it mean your future already exists? Here's the kicker. The physics tells you about coordinate assignments, how events are labeled past, present, future relative to a frame. The physics does not by itself tell you what exists in the metaphysical sense. That's where interpretations enter. And yes, the block universe interpretation says if all observers have equally valid time coordinates, then it's natural to treat all events as equally real in space-time. Another view, sometimes associated with presentism, says only the present exists, but then struggles with which present. A third family says the universe grows as time passes. Relativity forces the problem. It doesn't hand you the final philosophy. Let me pause here, because this is where videos usually cheat. They say, relativity proves the block universe. It doesn't. What it proves is that you can't define a universal simultaneity across all observers. The block universe is a way of making peace with that. Now here's something even stranger. Even though simultaneity is relative, the structure of space-time gives you invariant quantities, things everyone agrees on, like the space-time interval between events. That's why physics still works. It's not chaos, it's geometry. Fifth term, proper time, the time measured by a clock moving along with you. Your wristwatch time along your path through space-time. Proper time is what you personally experience. It's your time. And relativity says different paths through space-time accumulate different proper times. And we've tested that. Layer 2, 1318 min. Complicating factors, experiments, plus history. Now here's where it gets interesting. People didn't accept weird time because it sounded cool. They accepted it because experiments cornered them. Start with a historical anecdote. In the late 1800s, many physicists believed light traveled through a medium called the luminiferous ether, like sound travels through air. If Earth moved through this ether, the speed of light should vary with direction, like running into the wind versus with the wind. Albert Michelson and Edward Morley tried to detect that effect with an interferometer. Their famous result did not show the expected ether drift. Strong evidence against a stationary ether. You might think that experiment directly proved Einstein. It didn't, not uniquely, but it helped create the crisis. If light speed seems stubbornly constant, then either the ether theory gets weird or space and time get weird. Einstein took the space and time get weird route, but he did it with a clean principle. The laws of physics, including the speed of light and vacuum, are the same in all inertial frames. Now jump to a modern concrete test with clocks. In 1971, Joseph Hofla and Richard Keating flew atomic clocks around the world on commercial airliners, eastward and westward, and compared them to reference clocks on the ground. The flying clocks disagreed with the ground clocks by tens to hundreds of nanoseconds in the directions predicted when you include both special relativistic speed effects and general relativistic gravitational effects. Nanoseconds again sound tiny, but if you're building synchronization networks, satellite systems, or high-frequency trading timestamps, nanoseconds are the difference between correct and wrong. So the time is relative part is not optional. It's not a vibe. It's part of the machinery of the world. Now, a common misconception and a failed theory in casual conversation is that time dilation is just about your clock runs slow in some absolute sense. But actually, each inertial observer considers themselves at rest and their local clock normal. It's the comparisons between frames that produce the differences. And yet, your proper time is still yours. You live along one world line. You don't live in all frames. So where does your feeling of flow come from? That's where neuroscience, thermodynamics, and information theory start whispering. But we must be careful. Those aren't part of special relativity itself. They're extra layers. Layer 3. But wait. There's more to this story. The block universe idea is often described like this. The universe is a four-dimensional block of space-time. Events are like points in that block. Your life is a long curve through it, your world line. You experience it sequentially, like reading a sentence, but the sentence exists all at once. This is not poetry. This is fact, at least up to the geometry. Minkowski's space-time formalism is a standard way of representing relativity. But the step from space-time is a 4D manifold in the math to all times exist equally in reality is a philosophical move. It's motivated by the relativity of simultaneity, but not logically forced by it. So here are competing views you should actually know exist. Eternalism, block universe, past, present, future are equally real. Passage is perspective. Presentism. Only the present exists. The past existed. The future doesn't. Growing block. Past and present exist. The future does not yet. The block grows. Relativity makes 2 and 3 hard to state cleanly without picking a preferred frame, because the present isn't frame invariant. Now, some of you might be thinking, if the future exists, doesn't that kill free will? And yet, even if the block picture were true, it wouldn't automatically tell you whether the universe is deterministic. Determinism is about whether the laws and state fix the future uniquely. A block universe can be deterministic, but it could also be a block that includes indeterministic outcomes, still there in some sense, depending on your interpretation of probability. Here's something even stranger. Your brain experiences time with a thick now, a specious present, maybe a fraction of a second wide. But physics doesn't deliver that thickness. Physics gives you events and intervals. So where does now come from? Inference. A plausible story is that now is a cognitive construction built from memory integration and prediction, like a camera that buffers frames to make smooth video. That would explain why your experience is continuous, even though neural processing takes time. But that is neuroscience territory, not derived from Einstein's equations. Now let me take you deeper. If now depends on your motion, then your future right now is not a single answer. It's frame dependent. In one frame, an event is future. In another, it may be present. That's not a contradiction. It's how coordinates work in relativity. And here's the discomfort. Your intuition wants a cosmic present to protect the idea that the future is open. Relativity doesn't give you that protection, but it also doesn't take it away cleanly. So what do we not know? We don't know whether passage is fundamental or emergent. We don't know whether time's arrow, why you remember past not future, is fully explained by entropy and boundary conditions, or whether deeper physics is involved. And we don't know which metaphysics of time is correct, because metaphysics isn't measured the way clock rates are. Relativity gives you constraints. It does not give you comfort. Now let's zoom back down to human size, because you don't live in Minkowski diagrams. You live in mornings, deadlines, and late-night conversations where the room feels suspended in a single moment. When I look at a clock, I don't feel coordinate time. I feel urgency. I feel the quiet terror of a year passing faster than the year before. Do you feel that? Do you ever notice that your memories aren't arranged like a timeline, but like a pile of photographs, some vivid, some missing, some mislabeled? And yet the physics we've been discussing says your life is a continuous thread of proper time along your world line. It's not a slideshow. It's a path. Here's a poetic passage because sometimes precision needs tenderness. Time feels like a door that keeps closing behind you. You don't hear the latch, but you feel the narrowing hallway. And still, you keep walking, because walking is what living is. But here's the unity moment. You are not separate from this. Your heartbeat is a clock. Your metabolism is a chemical timekeeper. Your neurons are timing devices that coordinate with each other through signals traveling at finite speeds. You are, in a literal sense, a time-making machine embedded in space-time. So what happens to the fear? If you hear your future exists somewhere, you might feel trapped, like your choices are already written. But notice what your experience actually is. You deliberate, you imagine outcomes, you feel regret, you change course. Even if the universe were a block, your deliberation would still be one of the events in it. Your deciding wouldn't become fake, it would become part of the structure. Now I find this practical implication strangely calming. Relativity teaches you humility about perspective. If now depends on the observer, then your personal crisis, your urgent right now, is not the universe's emergency siren. It's your local weather, real, meaningful, but not cosmic. And that can soften the edges. Past, present, future. You remember the past because your brain stores records. You experience the present as the integration window of perception. You anticipate the future because prediction is survival. That timeline is a biological strategy layered on top of physical time. And that means even if physics doesn't hand you a universal present, your life still has one. Made by you, with everyone around you, in the only way it can be made. So what does this mean for you? It means the disturbing idea your future could already exist in someone else's now. Doesn't have to be a cage. It can be a lens. Here are practical takeaways, small but real. Stop worshiping the imaginary universal clock. Your stress often assumes a cosmic schedule. Relativity whispers there is no cosmic right now, only local frames and local lives. Use proper time as a metaphor for attention. Proper time is the time along your path. Your attention is the experience along your life. You can't live other world lines, but you can choose how fully you inhabit yours. Let disagreement about now train empathy. If observers can legitimately disagree about simultaneity, then humans can certainly disagree about priorities and still both be sane. Recognize the difference between physics and interpretation. The clock experiments are real. GPS corrections are real. The block universe is one story that fits those constraints, not a certified final answer. Make peace with uncertainty without abandoning rigor. The most intellectually honest stance is, we know what the equations do. We know what clocks do. We don't fully know what time is. This is the most remarkable thing about it. Relativity doesn't just change a number on a clock. It changes what you're allowed to mean when you say now. And once you see that, you can't unsee it. We started with a simple action, watching a second-hand tick, and a disturbing question. Which tick is now? Then we saw that in Einstein's relativity, simultaneity is not universal. Different observers carve space-time into past, present, future differently, using consistent rules. We grounded it in reality. Experiments and technologies that rely on relativistic time, from atomic clock flights to GPS corrections, and we arrived at the edge of philosophy, where the block universe is an interpretation some people embrace and others resist. We didn't pretend it was settled. We did something better. We looked straight at the constraint the universe gives us. Now I have a question for you, and I want it personal and specific. When was the last time you felt completely trapped by the future? And did that feeling come from the universe, or from your idea of right now? Leave your answer in the comments. I read them. I learned from them. Thank you for thinking about this with me.